Well, hello everybody. What I need to do with you today is I need to cover section 5.2 and 5.3 with you. What they talk about are the inverses of the cosine, sine, and the tangent. If you're in class today, we would have gave you back your test. We would have answered any questions over that video that you watched after the test over how to use the sine, cosine, and tangent. It should have been review from your geometry days. Now, what I need to make sure I can do with you today is by the end of this lesson, these terms may not sound familiar to you right now, but by the end of the lesson they'll need to. By the end of the lesson I'll need you to be able to do each of the following. Know what we mean by restricted domain. We're going to talk about the sine, cosine, and tangent graphs again today, but we're going to only use a partial graph. You'll see why here pretty soon. I'll need you to also know the domain and the range of the inverse functions. You'll see those pretty quick. And then the easier part of the day, once we get through with the thinking part, is be able to write equations and find unknown angles. We touched on that last class already, so that part won't be tough for you. What you make sure that you have in front of you, make sure that you have a calculator, of course, and then you should have our class notes. I'll move right along in the video. My goal is to have this thing done in about 30 to 35 minutes, so it's not a killer video for you. So hang on for the ride, and here we go. Guys, here's where I'm going to go first. We're going to talk about the inverse cosine function. So think about this for a second. I've given you the graph of the cosine function. Well, guys, today I want to find the inverse of the cosine function. We did inverses earlier in the year. One thing that we want to happen whenever we find the inverse of a function, we want it to pass the horizontal line test. Remember, guys, the horizontal line test looks something like that. If it passes the horizontal line test, then I know my inverse will also be a function. If it does not pass the horizontal line test, then it's not going to be a function. Well, we want our inverses to be a function. So here's what I got to do. I got to consider this cosine function here. I need to pick a portion of that graph so that it would be 1-to-1. Well, there's a lot of different pieces to pick. So I'm going to switch gears with you with just a second and then show you something. If you would, get your calculator out real fast. And I'm going to launch mine for you. And guys, if you would, make sure that you are in degree mode. So hit your mode button, come down and make sure that you're in degrees. I want you to see degrees, but we'll talk about them in terms of radians. But I'm sure that you'll see degrees better. So guys, here's what I'm going to do. If you would, we're going to hit inverse cosine of -1. So I'm just going to do this. I'm going to go second cosine. So you should see cosine -1, and then I'm going to put -1 inside there. I'll get to more of what you're finding here in a little bit, but right now I just want you to see some numbers. So inverse cosine of -1 is 180 degrees. So I'm going to put 180 degrees right there. And then I'm going to go to the next one. I'm going to go inverse cosine of -0.75. Notice that my calculator gave me about 138.6 degrees. So that's going to be about 138.6 degrees. And then guys, just one more, then I'm going to fill them in. The next one I'm going to do is inverse cosine. Oops, I said inverse cosine of -0.5. And like I said, if you're not getting these numbers, guys, you're not in degree mode. So this answer right here is 120 degrees. Now, so that I don't keep tapping on my calculator in front of you, when you do inverse cosine of -0.25, you should get about 104.5 degrees. When you do inverse cosine of 0, this came out to be 90. This one came out to be about 75.5 degrees. This one came out to be about 60 degrees. This one came out to be about 41.4 degrees. And then inverse cosine of 1 wound up being 0 degrees. I want you to notice something, guys. I allowed you to type in basically any number between -1 and 1. What would have happened if I would have let you type in bigger numbers? Well, watch this. Let's go inverse cosine of something like 2. Once I hit enter, notice that I get an error. Well, the reason I get an error is because the range of the cosine function is from -1 to 1. That means you're not allowed to type in anything bigger or smaller than a 1 or -1. So I'm only allowed to type in -1 to 1. Now notice what my calculator gave me. It gave me numbers between 0 and 180 degrees. Our question is, why is that? Why did my calculator only give me those kind of numbers? Well, here comes some thinking for us. I need to restrict. I need to pick a portion of this graph so that it would be 1 to 1, pass the horizontal line test. I'm going to come back to this slide in here in just a second, but here's some criteria that we need to think about. And this will be true whether I'm dealing with cosine, sine, or tangent. It says many of the x values contain the same y values. For this reason, in order for the inverse of the cosine function to be a function, the domain must be restricted. There are many possible restricted domains. Here are the 3 criteria that's going to be key for us. It says the domain should include the angles 0 to pi halves, the 0 to 90, because they are the measures of the acute angles of a right triangle. Whenever we drew our reference triangles, guys, remember what kind of angles showed up in these? Usually a 30, 60, 90, or 45, 45, 90. So I need to make sure I include those angles. The second criteria said it should take on all values of the range. That means I should have the positive values, and I need to also have the negative values. And then the third criteria that we need to fulfill is we need it to be continuous. Okay? So now come back to my first slide for just a second. Look at your sine graph. I need it to contain the positives and the negatives. I need it to be continuous, and I need it to contain all the values within the range. So if you start looking at this, this really represents quadrant 1. This really represents quadrant 2, quadrant 3, and quadrant 4. I can also put quadrant 4 over here. So I'm going to show you 2 ways to think through this. I definitely have to contain quadrant 1, because that's 0 to 90. So I definitely have to contain this piece of my graph. I got to contain right through here. Well, does it make sense if I continue on and include this part? I'm going to have the positives and the negative. Notice what our calculator gave us. It gave me 0 to 90 and 90 to 180. So the domain that the calculator is going to use is going to be between 0 and pi. I also want you to think about this. Think about all students take calculus. All trig functions are positive in the first quadrant, only the sine in the second quadrant, only the tangent in the third quadrant, only the cosine in the fourth quadrant. Well, I got to include quadrant 1. I got to include quadrant 1 because that's my positives. If I look over here, I can pick up the negatives. So there's my 2 quadrants that I want. I can't use quadrant 4 because then that would all be positive. So I want to include 0 to pi. Okay. So come over to right there for a second. This will be at the bottom of your page. Here's the piece of the cosine graph that we're going to include. We're only going to include the piece that goes from there to there. Quadrants 1 and quadrants 2. Here's what I've done for you. I've named the 3 major points on that graph for you. You can write those down if you need. You can always pause the video. But notice at 0, there's 1. At pi halves, it crosses the x-axis. And at pi, it's negative 1. Well, for the inverse, I need to flip those points around. My x's become my y's become my x's. So I've flipped each of these ordered pairs. Instead of 0, 1, I got 1, 0. Instead of pi half 0, I got 0 pi halves. Well, look at what happens when I graph these. I've got the point 1, 0 right there. I've got the point 0 pi halves, 1.4 something, 1.5 something. And I got negative 1 pi. So here's the inverse graph. The big part that I need you to have so far, guys, is this. We have to restrict the cosine graph right now because it goes on forever. It fails the horizontal line test. So, the domain of the cosine graph will be 0 to pi. My range is still negative 1 to 1. That's what we mean by restricted domain. Now, the range of the inverse cosine then, I'm just going to flip those around. The domain is going to be negative 1 to 1. My range is going to be 0 to pi. Here's what this says in terms of your calculator. If your calculator was talking to you, it's saying, hey guy, you can plug in any number into me from negative 1 to 1. In return, I'm going to give you answers between 0 and 180 degrees, which we're going to call 0 to pi. That's what that says. I got another one coming up for you to think about, but let me show you the easy part of this. If you would, make sure your calculator's in degree mode again, and we are going to go find inverse cosine of radical 2 over 2. And I'll explain to you what you're finding. So I'm going to go inverse cosine of the square root of 2, close that off, divided by 2, close that off, and check out what your calculator gave you. It gave you 45 degrees. The answer is 45. We're going to convert it to radians here in just a heartbeat, but here's what your calculator just did for you. It says this. There's a triangle out there that has a cosine of radical 2 over 2. Radical 2 over 2 is positive, so I must be in this quadrant right here. And cosine is going to be radical 2 over 2. Your calculator just told you that the angle of this that triangle is 45 degrees. That's what it found for you. If you would, let's go inverse cosine, I'm typing in the next one now, of negative 0.5. And then I'll explain to you what you're finding. Once I hit that, it looks like 120 degrees. That's the answer. You don't have any more work to do. Don't worry, I'm going to come back and convert these to radians in just a heartbeat. Well, here's what this is saying. There is a triangle out there somewhere that has a cosine value of negative 1/2. You can either put that there or there, in the first quadrant or the second quadrant. Well, since it's negative, guess where you're going to put it? You're going to put it right in the second quadrant. You're going to fix it up to where the cosine is negative 1/2. So what did your calculator do for you? It told you to get there, you're going to have 120 degrees. So that's what you're finding, guys. To convert these to radians, we know that 45 degrees is really pi fourths. I know 120 degrees is 2 pi thirds. If you couldn't do those in your head, no big deal. There's 120. I'm going to divide it by 180. I'm going to go math, enter, and put a pi with it. You can pause the video if you'd like, but then the other couple here, arc cosine is another name for inverse cosine. Kind of in calculus, you'll see it written as arc cosine, but that's the same thing as inverse cosine. If you type that in your calculator, guys, you're going to get 180 degrees, which is about pi. Okay. Now, I'm not going to do the next couple with you because it's the same thing. You just type it into your calculator, round it to the nearest tenth of a degree. So that's all you're doing on that. But guys, that's the thinking that we got to do for the sine and the tangent. But we're going to do it a little quicker now. I'm going to come back to that application of the inverse cosine, that Landsat, because I want to get the simple math in you. Okay, guys, I'd like to do the same thing I did for a second ago. Here's the sine graph. Notice that once again, it is not continuous. I mean, it is continuous, but it's not one-to-one. So guys, I went ahead and filled these out for us. I found those a while ago. So if you would, put those in. When I went inverse sine of -1, I got negative 90 degrees. And then I got about 48.6 degrees. And then I got negative 30 degrees. And then I got about, skipped a screen, then I got about negative 14.5 degrees, that's a 4. And then I got 0. And then I got about 14.5 degrees again. And then I got 30. And then I got about 48.6. And then I got 90. So guys, here's the thinking. I could try to plug in a number bigger than 1 or smaller than -1. If I try that, second sine of 1.2, I'm going to get an error again. The reason being, you can only use numbers less than 1, greater than -1, just like on the cosine. Now I want you to notice what kind of answers these gave me. If I think about the quadrants, where I got all students take calculus, notice that it gave me some numbers in quadrant 1, 0, 14, 30, 48, 90. Notice that it also gave me numbers in quadrant 4. We got to figure out real fast, how come it didn't use quadrant 2? Well, look at quadrant 2. They contain positive sign values. So I would have got a repeat of 0 to 90. So on the sine function, here's what they're going to do to restrict the domain. My domain is going to be restricted from negative pi halves to pi halves. Look at my graph real fast. If I try to go 0 to pi, I failed the horizontal line test. Failed it miserably. But if I use the first quadrant and the fourth quadrant, there it passes the horizontal line test. So the range will still be -1 to 1. For the inverse sine then, the domain is going to be -1 to 1. The range is going to be negative pi halves to pi halves. So guys, here's what this says. Whenever we hit inverse sine, your calculator is telling you this. You can type anything into me between -1 and 1 inclusive. I am going to give you in return numbers from -90 to 90. I will not give you any numbers between 90 and 180, and I will not give you any numbers between 180 and 270. Okay? So that's what that means. So guys, in terms of all students take calculus, when we go to think about this, we got to include the first quadrant. That's a given. So you've taken care of the positive values of sine. Ask yourself where the negative values of sine are. They're right there. So I need to use negative pi halves to pi halves. Okay. So real fast, when I think of the sine function, its restricted domain is going to be negative pi halves to pi halves. And my range is going to be negative 1 to 1. When I think about the inverse sine graph, my domain is going to be negative 1 to 1. My range will be negative pi halves to pi halves. Once again, the calculator says type in whatever you want as long as we're between negative 1 and 1. I'm going to give you numbers between negative 90 and 90. So that's how that part works. Guys, and then the graph of it looks like that. Same thing as the cosine. I just flipped around the points for you. So there's one of our graphs. There's the other of our graphs. Okay. If you will, flip over to that. I'm not going to do all of these because they're just like plugging in the cosine graphs. So I'm going to launch my calculator. Let me clear that for you. I'm going to go inverse sine of negative square root of 2 divided by 2, just like we did earlier. I'm going to hit enter. Notice that my calculator gave me, oops, I typed that in wrong. I needed square root of 3 over 2. So let me get right back to this. And then let me hit enter. And then notice that it gives me negative 60. So my answer is negative 60 degrees. Okay. And then let's quickly convert that over to radians. So I'm going to get negative pi thirds. But guys, I can do the others with you, but we don't need to. You're going to do inverse sine of negative 0.5, second sine, negative 0.5. Calculator tells me that's going to be negative 30. Convert that to radians, negative pi sixth. And then these type in the same way. On this one, just make sure you're in degrees, and we're going to round that to the nearest tenth. Okay. I do want to talk about number 5 and number 6 real fast. Guys, if you would, type in number 6 there for me. I'm sorry, number 5. I'm going to go inverse sine of 60. Notice what happens when I hit enter. The answer is that 60 degrees. Here's why that is. This says, hey, to find the sine of 60, I'm going to draw a triangle, put a 60-degree angle right there. The sine says, hey, there's a triangle out there that you could use to find the sine of 60. Go find me that angle. Well, they're kind of inverses of each other. But it's not going to work on this one. The reason it worked over here, the sine uses quadrant 4 and 1. Check this one out, though. If I go negative pi fourths, negative 5 pi fourths, 5 pi fourths is going to be way over here. We don't use the third quadrant. If you type this in your calculator, plugging in 180 in place of pi, it's going to give you negative 45 degrees, which is equal to negative pi fourths. The reason it did, it won't give me an answer in the third quadrant. It'll come back and either put it there or there. So be careful there. And then guys, look at your number 7 if you would, before I move on to the tangent. It says an 18-foot ladder leans against a building. Express theta, the measure of the angle the ladder makes with the ground, as a function of h, the height of the ladder, the top of the ladder. Well, here's what I got going. I have some building right here. Those are supposed to be windows or something. And then I've got an 18-foot ladder. And I've got my ground, and I've got the angle that it makes with the ground. And then we're calling this height right there h. So really, just to draw you a better picture, here's what I got going. I got a hypotenuse of 18, I've got a h for height, and I got a theta right there. So now it says, find an equation for theta. Well, I'm going to do this. This is the opposite. This is the hypotenuse. So I've got sine of theta equal h over 18. To solve that for theta, theta is going to be inverse sine of h over 18. That's your answer for now, because you weren't given a certain height to look at it at. Then it says, describe all the sets of values for h. Well, my height can be anywhere from 0 to 18. I can't include 0 and 18, because at 0, I'm on the ground, and at 18, I'm touching the wall. My whole ladder's up against the wall. So I haven't formed a triangle. So h will be between 0 and 18. Your theta value can be anything from 0 degrees all the way up to 90 degrees. Notice once again I didn't include them because I wouldn't have a triangle. Okay? And then guys, let me hash through tangent. It's going to be pretty easy. I'll just talk about the main points of it. The inverse tangent's a little bit different. Here's our thinking on the tangent function. Remember when we graphed the tangent function? It had a bunch of asymptotes in there. The first one was at pi halves. There's another one at negative 3 pi halves. There's also one at negative pi halves. Think about this for just a second. Let's go all students take calculus again. I definitely got to include quadrant 1 because that's our angles of the right triangle. Now I need some negative values of tangent. Well, they happen here and here. So I got to decide which quadrant to use. I got to use quadrant 4. Here's how come. Remember guys, if you go tangent of 90 real fast in your calculator, if I go tangent of 90 degrees, notice that I get an error. Remember, we have an asymptote at 90 degrees. So I can't include quadrant 1 and 2. I got to include quadrants 1 and 4. Here's what that means for us. When we deal with the tangent function, our restricted domain is going to be from negative pi halves to pi halves. That's going to be our domain. Our range then is going to be negative infinity to infinity. And guys, I've got to correct something real fast. These are parentheses on those. You can't include them because those are asymptotes. And then my range is going to be negative infinity to infinity. So that means when we talk about the inverse tangent function, the domain is going to be negative infinity to infinity. My range is going to be pi halves to negative pi halves to pi halves. Okay? And guys, what I did here is I gave you the graphs of them. Here's the graph of our regular tangent. Notice that it only goes from negative pi halves to pi halves. But notice the range is negative infinity to infinity. When we do the inverse tangent, it flips around. My asymptotes become right there at the pi halves, and my domain goes forever. Okay? Guys, the easy part is the calculator part. We could type that in our calculator and do like what we've been doing. Okay, guys, if you would, let's jump over to almost my last example here. That example number 3 down there on the tangent. Then I'd like to bring it to a close, and then my video is going to be about 35. I was shooting for 30, but oh well. Guys, here goes my example 3. A plane flying at an altitude of 32,000 feet descends at a constant angle, theta, to an airport runway X miles away. Well, here's what I got going so far. I've got my plane up here. That's a plane, if you can't tell. And right now that plane is at 32,000 feet. Down along the ground here at some point starts a runway. So the plane's going to come down towards this runway. Guys, the key thing on this though, it says it descends at a constant angle. This is called the angle of depression. There's the horizon. The angle you're looking at is right here. Going back to your geometry days, parallel lines, alternate interior angles are the same. So here's the angle that I'm working with. And then it says an airport X miles away. So there's my picture. My part A says this then. Write an equation for theta as a function of x. Well, when I look at this, it looks like the opposite and the adjacent. So tangent. So I'm going to go and say tangent of theta equal 32,000 over x. To solve this thing for theta though, theta is going to be inverse tangent of 32,000 over x. At this moment, we can't solve this because we haven't been given an x value. So that's my answer so far. Now let's do part B. It says if x equals 40. Now remember guys, x is in miles. So when I go to figure out theta, I'm going to have inverse tangent of 32,000. I need to convert 40 miles to feet. And remember that there's 5,280 feet in a mile. Well guys, if you grab your calculator and type this in the way we have it, put extra parentheses around that right there, you should get theta to be right about 9 degrees. You know, think about a plane descending. If you're in 20, 30 degrees, man, that is a fast descent. You don't want to be there. Okay? So guys, if you would, if you got a little bit down there where it says putting it all together, here's the key points that I want to get in you today. Think about all students take calculus. If I'm dealing with the cosine graph and the inverse cosine graph, the restricted domain of the cosine come up here. You got to use the first quadrant, and you can't use the fourth quadrant, so you got to use the second. So your restricted domain is going to be 0 to pi. Your range is going to be negative 1 to 1. That way it's 1 to 1 is a function. That means when I switch this around, the domain of the inverse cosine is negative 1 to 1. The range is going to be 0 to pi. Once again, you can type these numbers into your calculator when using the inverse cosine. These will be your answers. If I do the same thing for the sine, I got sine theta and inverse sine theta. Remember your restricted domain. You got to use quadrant 1 again. You can't use quadrant 2 because that's also positive. So my domain is negative pi halves to pi halves. My range is going to still be negative 1 to 1. That means for the inverse sine, your domain, the items that you can type into your calculator, are negative 1 to 1. The range is going to be negative pi halves to pi halves. Okay. And then last but not least, let's talk about the tangent and the inverse tangent. Tangent's got to definitely use the first quadrant, and it's got to use the fourth quadrant because of this asymptote right there. So the domain is parenthesis, be careful, I messed that up earlier, negative pi halves to pi halves. My range is going to be negative infinity to infinity. When we flip that around, my domain becomes negative infinity to infinity. My range becomes negative pi halves to pi halves. The values my calculator will give me. Okay, guys, that's 5.2 and 5.3. Hopefully you did pretty well on it. Your assignment, of course, is on OneNote. It's got some 5-1 material on there, sine, cosine, and tangent, and then some 5.2 and 5.3. Good luck with it. Buzz into myself or Miss Dinahan if you have any questions. Good luck to you.